What I desperately wanted to do with that video was to try to get you guys to understand that square roots of negative numbers are not just bored math people playing with shit. They actually exist. They do exist. We just don't ever, when he kept picking up that graph, that's a very strange thing to think about. But there's a whole other axis. There's a whole other thing that we don't graph because, for one thing, it would be very hard. Yes?
So the red line discovered 0 and then fell. I think it's because they tried to divide by it.
Maybe. You never want to divide by 0. It's all fun and games until you divide by 0. And then civilizations fall. Shit. So, let me pull back over to here. If you want to, you can go back to the Math 285 link. You can pull that up. You can look at some more of the series. If you want to kind of blow your mind a little bit. It's really, I think, do you think he's explained it on a decent level? Were you guys able to follow for the most part? No? I'm sorry. There was a little bit with the x squared plus 1 thing. We haven't done a lot of graphical interpretation of answers, right? But I would hope that most of the rest of it was at a decent level to kind of get. The one thing he talks about in a later video is, let's see if I want to do this. I'll do that in a minute. I'll show you one little cool thing about this. Let's first start off with defining what this is. So we need to accept that this exists, but it is kind of clunky. You guys see it? I don't want to always write square root of -1. It's a little bit clunky. So we give it a symbol. Same way we gave 3.14159 blah 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 a symbol pi, or 2.71828 blah blah and the symbol e. I don't know if anybody ever seen e, but everybody knows pi, right? So we gave those symbols so I don't have to try to write out a bunch of the places to show what number I'm working with. So we're going to give this a symbol. And not surprisingly, the symbol we give it is related to its stupid name. In engineering, now here's a really cool physical application of complex numbers. When you have electricity flowing, you have an electric field and a magnetic field, and very often the magnetic field is captured in the imaginary parts of something. So imaginary parts of an equation or a solution to an equation would relate to the magnetic field of something. Okay, so we're not going to get into the physics, don't worry. But if you're an electrical engineer, they actually use the letter J for complex numbers just because they don't like math people. So they want to be different, right? It's like the Sharks and the Jets from West Side Story. When you're an engineer. All right. You ever seen West Side Story? Okay, good. Okay. So now watch this. So let's do some really basic manipulations with this. I mean, so this is by definition. This is not, I can't show you the work. We just define this to be the letter I. So for example, what would the square root of -4 be in terms of I? Well, I can break this up into the square root of 4 times the square root of -1. Is that cool? Just like we did with square root of 50 and stuff. Square root of 4 is 2. Square root of -1 is defined to be I. So somebody asked earlier this semester if I said square root of -16 or something, and they wrote, what would the square root of -16 be? 4i. They said, if I write 4i, is that okay? I'm like, shit, yeah, why not? But I wouldn't take it off if you didn't. Now I would. Now you know what the square root of negative number is. It's that. Now I understand on one level you're all like, well, you just rewrote the bad part in terms of I. Good job, yay. But it makes it easier to work with, and this does exist. It does. So let me come back to that this does exist idea. Stay with me now. Oh, you guys are all excited. Do you see how, I really want you to understand that the amount of algebra we're going to do with these are not going to be excessive. Was this difficult? No. If you realize this is just a definition, then these are easy. These are easy. Okay. Let me try to show you this next little thing. If I multiply 1 by -1, what do I get? Do you see how multiplying by -1 is a full, like not full, but it's not time. It's a half rotation. You guys see what I'm saying? Oh, do you love this? You gotta love this. What the hell do I mean? If I multiply 2 times -1, it's gonna go from 2 to -2. You guys with me? It's a very strange way. I'm not saying suddenly change how you multiply. This is nothing that big. This is just a way to represent it. And to be honest, it's the more correct way to represent it. But still keep doing it the way we've always done it. It doesn't change that. So what's the square root of -1? It's going to be a half rotation. Now watch. If I multiply by -1 once, I get here, right? If I multiply by -1 again, I get back there. And why is that, of course? Because -1 squared is 1. It comes back to where it started. So a square root of -1 is like a quarter turn. This is what they meant by the x-axis has this imaginary part coming off of it this way. Now, how much of what I'm talking about right now do you have to understand to pass this class? None. At this moment. You have to understand what I'm talking about right now to pass this class. But it's going to make the next piece easier to remember. Now, just go with me. This is the real numbers. Let me do it like that. This is the imaginary numbers. So this right here, let me draw this again. You can do it, Jeff. This here would be I. So what's down here? -I. So what would this be? 2I. Isn't that crazy? Okay, so that's the imaginary axis. That's lateral. What's lateral? Who works out? Lateral is your side. So lateral just means to the side of. So here's my normal x-axis. The reason you wanted to call it lateral numbers is because they exist to the side of the x-axis. So they're imaginary numbers on this axis. Now, watch. Square root of -1 is a quarter turn, and where do I end up? I. So that's why square root of -1 is I. If I multiply by another square root of -1, now watch this. This is kind of neat. I got too much to write down here. I'm so excited. Sorry. If I take square root of -1, if I do I times I, if I do square root of -1 times square root of -1, what should I get? No? Yes. What's the square root of 7 times square root of 7? 7. Square root of 11 times square root of 11? Square root of -1 times square root of -1? -1. Bam. Bam. Imaginary numbers are the only numbers that allow for a negative output to a square. So I squared is -1. Why? Because what is this? Isn't this the square root of -1 squared? And what's the square and the square root 2? Cancel. So don't I get -1? Yes. Oh shit. This is why I kept saying the answer to certain things was no real number or not real or no real answer or something like that, because there are imaginary answers to some of those things. Because they do what we couldn't do before. Something times itself is negative. That's never possible with real numbers. Never. But with imaginary numbers, all day. All day long. Okay. Stay with me now. Shit. Sorry. So watch. I is square root of -1. I squared is -1. You see, like, if I do a quarter turn and another quarter turn, do you see how I end up at -1? What if I do another quarter turn? That would be how many i's? 1, 2, 3. I cubed, where do I end up? Negative I. So again, watch. What's I times I times I? Well, what's I times I? -1. What's -1 times I? Negative freaking I. And then if I do one more, I go back to 1. So what I just did is the last thing I'm going to write to you guys today. I just did this. I to the first is I. That's amazing. I squared is -1. I cubed is -I. I to the fourth is 1. So look, I to the fifth would start over again here. I to the 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th. It's what we call cyclic. And that's why this picture is it's cyclic. It keeps going over and over the same things. Do you see how that's a little bit like negative 1 itself? What's negative 1 to the first power? And what's negative 1 squared? And what's negative 1 cubed? But see how it repeats every second it repeats, right? Here it's every fourth because the square root of negative 1 is a fourth of a term. So of course it takes 4 times to repeat. Oh, it's a lot to drop on you, but oh well, too bad. I want to get that in your brain so it can really invade your dreams over the spring break. All right. Have a good break, guys. Oh, well, some of you guys, come to the lab, take that quiz.